Hello. Hello, am I audible, students?
Yes,
Yes,
sir.
sir.
So, last class, uh, what we have studied? Last class, we have studied about organic molecular complex, right?
Yes, sir.
So, how many types are there? Organic molecular complex? Classify organic molecular complex. How many types are
There are
there? Four
organic
types.
molecular complex, picric acid complex, queen hydron type, and polymeric complex.
Very good. So, organic molecular complex that are subdivided into four classes: drug and caffeine complex, polymer type, picric acid type, and queen hydron type. Okay, so last class we have studied about in detail that drug and caffeine complex, polymer complex, what type of polymer that may form complex with drug, then picric acid complex, butane picrate, and queen hydron complex. Already we have studied about that. So, can you tell me one example of this one polymer complex? কেউ একজন বলতে পারবে পলিমার কমপ্লেক্সের একটা এক্সাম্পল?
Sir, CMC or carboxymethyl cellulose.
That are example of polymer. I am asking one example of complex that will form with polymer. I think when we have studied about the application of complexation, when we have studied that time, I told this example of polymer complex. Can you remember one example? Very common example is there. কারো মনে পড়ছে? Povidone iodine. Can you remember? Povidone iodine. What is that?
Hello, sir. Sir, polyvinyl pyrovinyl সাথে কমপ্লেক্সেশন। হ্যালো,
হ্যাঁ, কমপ্লেক্সেশন পলিভিনাইল পাইরোলিডনের সাথে কার?
পাইরোলিনের সাথে আয়োডিনের কমপ্লেক্সেশনে পোভিডন আয়োডিন
ভেরি গুড।
কমপ্লেক্স।
Yes, very good. So polyvinyl pyrrolidone, PVP, that is a water soluble polymer, and it will form a complex with iodine. Then we will get povidone iodine complex, and this complex is also soluble in water. Okay, so povidone iodine, what is the use of that? What is the use of povidone iodine?
Antiseptic.
অ্যান্টিসেপটিক অ্যান্টিব্যাকটেরিয়াল
Hand rubs, soap was, etc.
Antibacterial and germicidal.
জার্মিসাইডাল অ্যান্টিব্যাকটেরিয়াল।
It is having antibacterial activity and germicidal activity. Okay, so we have completed that part. Today we will start the third classification. Total 3 classifications are there. First one is metal complex, second one is organic molecular complex, and third one is inclusion complex. Metal complex, first one, that are classified into 4 groups. কি কি আছে তার মধ্যে? মেটাল কমপ্লেক্স প্রথম যে ক্লাসিফিকেশনটা পড়েছিলাম, first classification that we have studied, first one, metal complex, that is classified into inorganic type,
Chelate, olefin type,
Chelate, olefin type, or aromatic type.
very good. So inorganic type, chelate, olefin, and aromatic type, 4. Then second one is organic molecular complex, that is also classified into 4 subgroups. And today we will study about the third one, that is inclusion complex. This inclusion complex that are also classified into 4 groups. Okay, first one is channel type, second one layer type, third one clathrate, and fourth one monomolecular type. Again, I am repeating, inclusion complex that are classified into 4 subgroups: channel type, layer type, then clathrate, and fourth one is monomolecular type. So one by one, we will discuss about that. So first we have to know what is the meaning of inclusion complex. Inclusion complex. These complex are also called occlusion compound. Occlusion, OCCLUSION, occlusion compounds, in which one of the component is trapped in the open lattice or cage-like crystal structure of the other. Okay, see that here I have written already. The class of addition compound known as inclusion or occlusion compound, which results more from the architecture of molecules than from their chemical affinity. One of the constituent of the complex is trapped in the open lattice or cage-like crystal structure of the other to yield a stable arrangement or complex. Okay. Now, here one thing you have to remember, the interaction is not due to the chemical reactivity. In cases of butadiene picrate, quinhydron complex, everywhere what we have seen, that is the interaction due to the chemical reactivity. But in this case, inclusion complex, the interaction is not due to the chemical reactivity. So then how complex will form? The complex will form because of the favorable molecular structure. The structure of molecule, that is cage-like structure. So that's why the drug that will easily accommodate in that cage-like structure of the other compound. And here the force of interaction are very weak. Okay, the force of interaction, that is very weak, and the interactions is not due to the chemical reactivity. Okay, now these are 4 types: channel type, layered type, clathrate, and monomolecular types. Channel lattice type, first we will study about that. Examples are deoxycholic acid with other complex, then urea and thiourea complex, then starch iodine solution, starch iodide. এটা তোমরা এর আগে পড়েছো, বলতে পারবে এটা what is this starch iodine solution? Hello, one test was there, starch and iodine solution. জানো এই টেস্টের সম্বন্ধে? Anyone? Hello, any idea about that starch iodine solution?
স্টার্চে আয়োডিন দিলে ওটা ভায়োলেট কালার হয়ে যায়, ওটা মানে ডিটারমিনেশনের জন্য।
Yes, that is the conformative test of starch. Okay, the compound is starch. How you will confirm? If you add iodine solution in starch, it will give blue color, starch iodine solution. So we can say that that compound is starch. That is the identification test of starch. Okay, so actually what type of complex will form? That is channel type complex. Then layer type, that is intercalate compounds between its layer. Example is clay montmorillonite complex. That is one example of layer type. One by one we will discuss about that. So channel type examples are deoxycholic acid with other complex. Here this starch iodine solution, that is very well known. We can say that that is also one example of channel type complex, in which iodine molecules that are trapped within the spiral of glucose molecule. Starch, that means glucose. So iodine molecule that are trapped within the spiral of glucose molecule. Okay, I will show you the figure how it will look like. The crystal of, same in cases of deoxycholic acid, the crystal of deoxycholic acid are arranged for forming a channel into which complexing molecule that will very easily fit. Okay, an inclusion compound is a complex in which one chemical compound, that means we can say that is host, it forms a cavity or channel in which molecules of a second compound, also we can say that is guest, that are entrapped. These complexes generally do not have any adhesive force working between their molecules and are therefore also known as no bond complex. Okay, an interaction that are present in between host and guest, that is very much weak. One of the component is trapped in open lattice or cage-like crystal structure of the other. Okay, so interaction present in between host and guest, that is due to suitable molecular structure. One compound is trapped in lattice or cage-like structure of the other compound. And in this case, interactions are due to suitable molecular structure, that is cage-like structure. And prediction of complex formation, in this case, that is difficult. In this complex, the host component crystallizes to form channel-like structure into which the guest molecule very easily fit. The guest molecule must possess a geometry that can be easily fit into the channel-like structure. Example, the deoxycholic acid. In detail, I have written here, see that. The cholic acid that can form a group of complex principally involving deoxycholic acid in combination with paraffin, organic acid, ester, ketone, and aromatic compounds, and with solvent such as ether, alcohol, and dioxane. The crystal of deoxycholic acid that are arranged to form a channel into which the complexic molecule very easily fit. Such specificity should permit the resolution of optical isomer. In chemistry, already all of you are studying that stereochemistry. In fact, camphor that has been partially resolved by complexation with deoxycholic acid, and DL-terpineol that has been resolved by the use of digitonin, which occludes certain molecules in a manner similar to that of deoxycholic acid. Okay, so it is a very good example that deoxycholic acid that will form a complex with paraffin or organic acid or ester, ketone, aromatic compound, or it may also form channel type complex with solvents such as ether, alcohol, and dioxane. In this case, the host, that means deoxycholic acid, urea, thiourea, amylose guest, amylose that are known as host, and guest is long unbranched straight chain compound. Example, paraffin, ester, acid, ethanol. Some other examples are also there. Starch iodine solution, already I told. Then urea methyl A lipolate. In this case, urea is the host. The well-known starch iodine complex is a channel type complex which consisting of iodine molecule which is entrapped within the spiral of glucose residue. Okay. So it is very easy to remember that deoxycholic acid with ester and starch with iodine. See that this is one example. Here the shape of that crystal is needle shape, and also we say that shape is needle shape crystal, and also we can say that hexagonal. It is a hexagonal channel complex which is formed by methyl alpha lipolate with urea. So in this case, urea, that is host or guest. In this case, urea is host or guest?
Sir, host.
Host. and guest is methyl alpha lipolate. Okay, so here it is the channel type complex in between urea and methyl alpha lipolate, where methyl alpha lipolate is a guest and urea that is host. Methyl alpha lipolate that will easily accommodate in the hexagonal structure of urea. Okay, so what are the various applications of this channel type complex? Applications are separation of isomer. For example, dextro and levo terpineol, which are separated using digitoxin. That is one applications of channel type complex. Then another one, in analysis of dermatological cream, long chain compound interfere and removed by complexation with urea. Okay, that is another one application. So these are the two main applications of channel type complex. One is separation of isomer, dextro and levo terpineol, and another one in analysis of dermatological cream, long chain compound interfere and removed by complexation with urea. Channels are formed by crystallization of host molecule. Host molecule are usually tubular channel. Some examples I have given, already I told, deoxycholic acid, urea, thiourea, amylose. And guest component that is usually long unbranched straight chain compound. Example already I told, paraffin, ester, acid, ethanol. Urea methyl alpha lipolate complex, starch iodine complex, all are examples of channel type complex. And these are very much useful for separation of isomer and analysis of dermatological cream. So this is the figure of channel type complex, that is methyl alpha lipolate with urea. Okay, so it will look like this. Then second classification is layer type. Here some compounds are there. For example, clay or montomorillonite. Now what is montomorillonite? Montomorillonite, here I have written, see that, clay or montomorillonite or bentonite. That is a constituent of bentonite. Now what is bentonite? Bentonite, that is one compound which is used for preparations of various cosmetic preparation. Cosmetic e khub besi use hoy bentonite. For example, face powder. Face powder contains bentonite. Okay, so montomorillonite, this is one constituent of bentonite. This bentonite or clay, they can entrap hydrocarbon. Here bentonite or montomorillonite or clay that acts as host, and guest molecule, that means hydrocarbon, alcohol or glycol. This clay, montomorillonite, bentonite, they can entrap this hydrocarbon, alcohol or glycol, and they form alternate monomolecular layer of guest and host. Okay, they can form monomolecular layer of guest and host. Their use are currently limited, but also you can say that they may be useful for catalysis of account of a larger surface area. Obviously, layer type, in cases of layer type complex, surface area will increase. Okay, so due to their large surface area, they can be used as a catalyst. Okay, they are used as catalyst. So in cases of layer type, host molecule, that is, example is clay, bentonite or montomorillonite, and guest molecule, that is hydrocarbon, alcohol and glycol. Okay, use is catalyst because of their larger surface area. One, clathrate. Spelling ta dekho, CLATHRATES, clathrate. So what is the meaning of that clathrate? Clathrate, that is another one example or classifications of inclusion complex, where a cage-like lattice in which the coordinating compound is entrapped. This line is very important. The clathrate crystallizes in the form of a cage-like lattice in which the coordinating compound is entrapped. Chemical bonds are not involved in these complexes. Okay, in the introduction part, already I told any chemical bond that are not involved in molecular inclusion complex. And only the molecular size of the encaged component is of importance. The stability of a clathrate, that is due to the strengthening of the structure, that is to the high energy that must be expended to decompose the compound, just as a prisoner is confined by the bars that prevent the escape. Okay. Detailed study of clathrate compound and showed that the highly toxic agent hydroquinone crystallizes a cage-like hydrogen bonded structure. The holes have a diameter of 4.2 Armstrong, and it permits the entrapment of one small molecule to about every 2 quinol molecules. Small molecules such as methyl alcohol, carbon dioxide, hydrochloric acid, that may be also entrapped in these cages, but smaller molecules such as hydrogen and larger molecules such as ethanol, they cannot be accommodated. So it is possible that clathrate may be used to resolve optical isomer process of molecular separation. Okay, so in cases of clathrate, one example is there, very good example, that is warfarin sodium. That is one drug, warfarin sodium, white color crystalline powder. What I told, example of clathrate is warfarin sodium USP. USP means United States Pharmacopoeia. So warfarin sodium, that is a clathrate of water and IPA. এই যেখানে বললাম যে ওয়াটারের সাথেও হয়, so water and isopropyl alcohol, and it is available as white color crystalline powder. See that here I have written, during crystallization some compounds it form cage like structure in which coordinating compound, that means guest, that is entrapped. Example is warfarin sodium. So warfarin sodium, that is a clathrate of water and isopropyl alcohol, IPA, and it is available in white color crystalline powder. Now from this figure, just look at this figure. It is a cage like structure, and where cage like structure formed through hydrogen bonding, this one, hydrogen bonding of hydroquinone molecules, and small molecules are entrapped here in this case. So the small molecules are entrapped into this cage, and this hydrogen bond that formed, that will form the cage like structure, and inside that small molecules that will easily entrapped, okay, to form a clathrate. So that is a example of clathrate where cage like complex formed through hydrogen bonding of hydroquinone. That is another one figure. See that hydroquinone molecule forming the cage, the same picture, just that is a schematic diagram, that how guest molecule that will enter into that cage, and it will look like a prisoner. So that's why I have written here, cage like structure formed through hydrogen bonding of hydroquinone molecules. Small molecules such as methanol are trapped in the cages to form a clathrate. Just a minute, আমার একটা ফোন আসছে। Sorry for interruption. So in this case, cage-like structure formed through hydrogen bonding of hydroquinone molecules. Small molecules such as methanol that are trapped in the cages to form the clathrate. Okay. So during crystallization, see that some compounds, they form a cage-like structure in which coordinating compound is entrapped. Example is warfarin sodium. Another one example, hydroquinone form cage with hydrogen bond and holes have diameter of 4.2 angstrom. And this can entrap methanol, carbon dioxide, and hydrochloric acid. Okay, so what are the various applications of that? Applications of this clathrate. So many applications are there. One application I am telling, synthetic metal aluminosilicate, that is also known as molecular sieve. Do you know what is sieve? Have you any idea what is sieve?
Sir, a net-like structure which can differentiate smaller particles and larger particles.
Yes. In size separation chapter already you have studied, na?
Yes, yes.
So different types of sieves are there. So this clathrate also we can compare with that. Clathrate, it is look like a this one sieve. That's why that is also known as molecular sieve. The best application of clathrate is synthetic metal aluminosilicate. Okay, you may note down this one. Synthetic metal aluminosilicate that are known to be used as molecular sieve. What is the use of this? These material are used to store gaseous substance, volatile substance, and toxic substance by the mechanism of clathrate. Okay, again I am repeating. Synthetic metal aluminosilicate that are known to be used as molecular sieve. And these material are used to store gaseous substance, volatile substance, and toxic substance by the mechanism of clathrate. Okay, so the clathrated guest molecule that can be later removed by a simple physical process. So that is the applications of clathrate. Okay, which can be used to store gaseous substance, volatile substance, and toxic substance. Okay, by the mechanism of clathrate. And the clathrated guest molecule that can be later removed by a simple physical process. Next, last one, that is monomolecular inclusion complex. It is very, very, very much important. Monomolecular inclusion complex. Okay, so what is that? It involves the entrapment of single guest molecule in the cavity of one host molecule. See that, look at that figure. This is a examples of monomolecular complex which is known as cyclodextrin. See that spelling, cyclodextrin. It is a cup-like structure, and inside that cyclodextrin some space is available. Okay, some space is available. So here cyclodextrin that is acts as host, and that inside that host or cyclodextrin some molecules they may entrap, that is known as guest. For example, aspirin. So aspirin molecule they can entrap inside that cyclodextrin, and the outer side of and inside that host, that means cyclodextrin, that is hydrophobic in nature. So outside is hydrophilic, inside is hydrophobic. So if the drug is hydrophobic, that means water insoluble, that type of drug that may easily entrap inside this hydrophobic core or hydrophobic cavity or hydrophobic interior. Okay, so here one example is aspirin. So aspirin solubility is less, So aspirin may easily entrap inside the cavity of the cyclodextrin, because inside that is hydrophobic in nature, and aspirin that is also hydrophobic. But the outside of this cyclodextrin that is hydrophilic in nature, that means water loving. So we can say that this cyclodextrin can be used to increase the solubility of poorly water soluble drug. Okay, see that the entrance cavity is hydrophobic, this one, and interior cavity is hydrophilic in nature. Single guest molecule entrapped by single host molecule, and here host is cyclodextrin. So what is cyclodextrin? Cyclodextrin, that is a compound, we can say that that is a cyclic oligosaccharide which contains minimum of 6 D-glucopyranose unit which are attached by alpha 1,4 linkage. What is cyclodextrin? That are a compound cyclic oligosaccharide which contains minimum of 6 D-glucopyranose unit which are attached by alpha 1,4 linkage. Okay, so cyclodextrin that acts as host, and the drug, poorly water soluble drug, that acts as guest. So the guest drug molecule that will enter into the host molecule, that means cyclodextrins. And what is cyclodextrins? That are cyclic oligosaccharide which contains 6 D-glucopyranose unit which are attached by alpha 1,4 linkage. See that cyclodextrins are cyclic oligomers of glucose that can form water soluble inclusion complex with small molecules and portion of large compound. And these compounds are biocompatible. Biocompatible means biologically it is compatible with body. Cyclic oligosaccharide do not elicit immune responses, and it have low toxicity in animal and human. So cyclodextrin is a very good compound to form a complex with poorly water soluble drug for increasing solubility. So cyclodextrins are used in pharmaceutical applications for numerous purposes, including improving the bioavailability of the drug. Obviously, if the drug is poorly water soluble and if we form the complex with cyclodextrins, the solubility will increase, and when solubility will increase, obviously the bioavailability that will be also increased. Macromolecular inclusion complex or molecular sieve, as they are commonly called, include zeolite, dextrin, silica gel, and related substance. All these atoms are arranged in 3 dimensions to produce a cages-like structure or channel-type structure. Synthetic zeolite that may be made to a definite pore size so as to separate molecules of different dimension, and they are also capable of ion exchange. Okay, now what is ion exchange? Ion exchange resins are there, different classifications are there in cases of polymer. ওগুলো পরে তোমরা ডিটেলসে পড়বে, জানতে পারবে। So cyclodextrins, that is a very good compound to form a complex, or also you can say that to increase the solubility of poorly water soluble drug, which will form monomolecular inclusion complex. See that monomolecular inclusion complex involves the entrapment of guest molecule into the cage-like structure formed from a single host molecule. So you can also say that cyclodextrins are a family of compound made up of sugar molecule bound together in a ring. That's why that is known as cyclic oligosaccharide. See that structure of cyclodextrin. CD means cyclodextrin. Inside that is hydrophobic, outside that is hydrophilic. That blue color, that is hydrophilic, outside that cyclodextrin, and inside the cage that is hydrophobic in nature. Interior portion is hydrophobic in nature. And they consist 6, 7, and 8 units of glucose, which is referred to as alpha beta, and gamma cyclodextrin. 6 glucopyranose unit, that means that is alpha cyclodextrin or alpha CD. If it consists 7 glucose unit, then that is known as beta cyclodextrin. And if it contains 8 units of glucose, then it is as gamma cyclodextrin. Now, among these 3 cyclodextrins, alpha, beta, and gamma, the beta cyclodextrin that is widely used. সবথেকে বেশি ইউজ হয় beta cyclodextrins among these 3 classifications, alpha, beta, and gamma. What is the reason behind this? Why this beta cyclodextrin is widely used other than alpha and gamma? Alpha আর gamma থেকে বেশি বিটাটা কেন ইউজ হয়? Because the inside structure of the beta cyclodextrins, the space available inside that beta cyclodextrins, that can easily accommodate any drug. স্ট্রাকচারটা এমনই যে তার মধ্যে যে কোনো ড্রাগ ভেরি ইজিলি এন্ট্র্যাপ হতে পারে। Because of that, beta cyclodextrin is widely used other than alpha and gamma. Now, cyclodextrins have truncated cone structure. This is cone structure with a hydrophobic interior cavity because of CH2 groups and a hydrophilic exterior due to the presence of hydroxyl group. Outside, that is hydrophilic in nature because of hydroxyl group, and inside, that is hydrophobic in nature, that is because of CH2 group. Okay. Now, see that here classifications of cyclodextrins. 3 types are there: alpha, beta, and gamma. In cases of alpha, 6 glucose units are there. In cases of beta, 7 glucose units are there. And in cases of gamma, 8 glucose units are there. Now see that this is alpha, beta, and gamma. See that internal space, internal diameter, that is less in cases of alpha than beta and gamma. Internal diameter in cases of alpha cyclodextrin, that is 4.7 to 5.3 Armstrong. Okay, and aqueous solubility of this, that is 4.5 gram per 100 ml. Sorry, 14.5 gram per 100 ml. Beta cyclodextrins, which is having 7 glucose unit, and the internal diameter is 6 to 6.5 Armstrong, and this is the aqueous solubility, that is 1.85 gram per 100 ml. And in cases of gamma cyclodextrin, it contains 8 glucose unit, and internal diameter is 7.5 to 8.3 Armstrong, which is having the highest aqueous solubility, that is 23.2 gram per 100 ml. In market, that are available in this name: alpha, that is alpha dex, beta cyclodextrin, that is beta dex, and gamma cyclodextrin, that is gamma dex. Okay. And the total height of this, that is 0.78 nanometer. So that is a very good complexing agent. By using this cyclodextrin, we can increase the solubility of poorly water soluble drug. ঠিক আছে, তাহলে যে কোনো ড্রাগের সলিবিলিটি বাড়াতে হলে আমরা সাইক্লোডেক্সট্রিন ইউজ করতে পারি। See that molecules of appropriate size and stereochemistry that can get entrapped in the cyclodextrin cavity by hydrophobic interaction by squeezing out water from the cavity. See that this is drug molecule, this is the hydrophobic cavity. So the drug that will easily accommodate inside that cyclodextrin. So beta CD and gamma CD, that are the most useful for pharmaceutical technology owing to their larger cavity size. সবথেকে বেশি এটা ইউজ হয়। Now, what are the various applications of monomolecular inclusion complex? So first, already I told, it can be used to enhance solubility. Example is retinoic acid. See that solubility is 0.5 milligram per ml. Retinoic acid plus beta CD solubility, see that initially the single retinoic acid solubility is only 0.5 milligram per ml, but when we have prepared complex with beta CD, the solubility is so much increased, 160 milligram per ml. This monomolecular inclusion complex also can be used to enhance dissolution. Example of drug famotidine or tolbutamide, spelling mistake আছে, tolbutamide, BU হবে, tolbutamide plus beta CD. So we can increase the dissolutions of this famotidine and tolbutamide by forming complex with beta CD. Then this monomolecular inclusion complex also used to enhance stability. For example, aspirin, ephedrine, testosterone, that can be form a complex with beta CD. Okay, so stability can be increased by the formations of complex with beta CD. Examples of drug aspirin, ephedrine, and testosterone. Beta CD that can be also used to form a complex for sustained release. For example, ethylated beta cyclodextrin plus diltiazem. Diltiazem, that is one drug, we can form one complex with ethylated beta CD. So the drug release from that complex, that will be slower. So that's why by formation of complex with ethylated beta CD, we can use this complex as a sustained release formulations, diltiazem plus ethylated beta cyclodextrin. So many other applications are also there. See that, to alter physicochemical and biopharmaceutical properties of the drug. So by the formations of complex with cyclodextrins, we can change physicochemical properties as well as biopharmaceutical properties of drug. Also, we can use as a chelating agent. Chelating agents that are used as antidote in heavy metal poisoning. Application আমরা পড়েছিলাম. In heavy metal poisoning, we can use this beta CD as a chelating agent. Then solubility enhancement of some drug, already I discussed. Then stability enhancement, already I discussed. That we can also use as a therapeutic agent, beta cyclodextrins, where in diagnosis of conditions such as kidney function or GFR. GFR means glomerular filtration rate. So for testing of kidney function, we can use these beta cyclodextrins. Also, we can use this complexation, this monomolecular inclusion complex, for assay of drug by complexometric titration, and for development of novel drug delivery system, we can use beta cyclodextrins. So one by one we will discuss in next class. Okay, application এ এখানে যেগুলো বললাম প্রত্যেকটারই একটা করে এক্সাম্পল আছে, with example we will discuss in next class. So today up to this. Okay, so total what we have studied today, the inclusion complex that are classified into 4 groups. First one is কি বললাম, প্রথমটা কি ক্লাসিফিকেশনের
Types.
channel type, then channel type, then second one layer type, third one class rate, and fourth one is monomolecular inclusion type. Okay, so with example, already we have completed this one with example. So monomolecular inclusion complex, sometime question may be asked, এটা সবথেকে বেশি জিজ্ঞেস করে কি what is cyclodextrin, how many types are there, why beta cyclodextrin is widely used, what are the applications of this monomolecular inclusion complex. Okay, so all these applications you have to remember. So that's why বইতে দেখবে অল্প অল্প দেয়া আছে, in details we have to discuss this one, the applications of this monomolecular inclusion complex. That is very very much important. Okay, so we have completed that classifications, only classification applications is remaining. So next class we will study the details about the applications of this monomolecular inclusion complex. Okay, so হ্যাঁ
61
বলো,
slide টা একবার দেখাবেন?
কোনটা
61 slide. 61.
this one না? Okay.
Yes, sir, yes. ওকে স্যার, লিখেছি।
Okay. So
স্যার
I think
58 টা একবার দেখান না।
this one.
স্যার 60 টা একবার দেখাবেন।
Okay, so glucopyranose unit এটা মনে রাখতে হবে তোমাদের। ডিফারেন্সটা হচ্ছে 6, 7, 8. Okay, alpha ক্ষেত্রে 6, in cases of beta 7, and in cases of gamma 8. Okay, very important slide this one. Okay, I think আর কারো কোনো ডাউট নেই, যদি থাকে বলো।
লেয়ার টাইপের গেস মলিকিউলের এক্সাম্পলটা কি বলবো?
Layer type, this one না, guest molecule এই যে হাইড্রোকার্বন, অ্যালকোহল and glycol, and host molecule is bentonite or clay. This clay molecule, they can trap hydrocarbon, alcohol or glycol. And the main importance of layer type complex is surface area is very much large. So that's why we can use layer type complex as a catalyst. Okay, so I hope this class will help you a lot. কারো কোনো ডাউট থাকার কথা না, খুব ইন্টারেস্টিং এটা। আর আই থিঙ্ক কারো ডাউট আছে? নো প্রবলেম না?
No, sir.
No, sir.
ওকে ওকে, তো ঠিক আছে, তাহলে এখানে ক্লাসটা শেষ করলাম। পরের দিন আমরা ক্লাসে অ্যাপ্লিকেশনটা ডিটেলসে পড়বো, অ্যান্ড হাউ টু এভালুয়েট মিনস মেথড অফ অ্যানালিসিস অফ কমপ্লেক্স, ওটা আমরা পড়বো। ঠিক আছে, ঠিক আছে, এখানে তাহলে শেষ করলাম। থ্যাংক ইউ অল।
Thank you, sir.